It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 371. Daniel's truck starts to accelerate by pressing the accelerator pedal while stationary, and the table above gives the distance x in feet that a truck has traveled at selected times of t in seconds. If both the velocity and the acceleration of the car is negative for t is between 0 and 4, which of the following could be the velocity of the truck in feet per second at time t is equal to? The key phrase is that both the velocity and the acceleration of the cars are negative, right, in this interval. So let's draw the graph of x roughly, and we will think about the velocity and the acceleration. So here is time t, and this y-axis is our x of t, the position or distance. Okay, when t is equal to 0, it's a 200. So let's say here is 100, here is a 200. So coordinate point is right over here. And when t is equal to 4, 1, 2, 3, 4 here, x is negative 320. So negative 100, negative 200, 300 here, so negative 20 somewhere here. Okay, so somewhere right over here. Right? Here it says velocity is negative. That means the position curve has to decrease, right? And also acceleration is negative, right? That means this position curve has to be concave down, right? So let's draw the graph roughly. Decreasing, concave down, that's gonna be like that, right? Okay, so we're trying to find the velocity of the truck at time t is equal to, right? So at t equal to, velocity of the truck, here we have a position graph, position curve, right? So the velocity is the slope of a tangent line at t is equal to, right? So at t is equal to slope of tangent line, it'll be like that, right? That's a tangent line, and slope of this tangent line is v prime 2. I'm sorry, v of 2, right? Because the velocity is the derivative of position, v of 2, right? Okay, so far so good. Here, when x is 1, we have coordinate here, that's 160, right? When t is equal to 1, okay? When t is equal to 3, we have negative 80. So this coordinate right here is negative 80, right? Okay, if we draw the second line that passes through these 2 points, then that's gonna be like that, right? That's the second line that passes through these 2 points, right? The second line that passes through these 2 points, is this, right? So far so good? Okay, obviously the slope of this tangent line has to be between the slope of these 2 secant line, right? The slope of this blue line, the slope of this red line. Does that make sense? Here, acceleration is negative, right? Acceleration is negative. That means slope is decreasing. Slope is decreasing, right? So slope of this blue line, this secant line, must be greater than this tangent line, but the slope of this red line must be less than this tangent line, right? Okay, let me write this. Slope of this blue line is m number 1. Slope of this red line, m number 2. Okay, so let's find the slope of this second line that passes through these 2 points. All right, okay, that's m1. So our m1 is equal to y2 minus y1. That's these two points, right? So y2 minus y1, 80 minus 160 over x2 minus x1, 2 minus 1. So that's a negative 80, right? Let's find M2. M2 is the second line that passes through these 2 points, right? So y2, that's negative 80, minus y1, 80, over x2 minus x1. That's going to be negative 160, right? So our slope of the tangent line, which is this, right? This must be, the value of this must be between negative 80 and negative 160, right? So let me write, we don't have enough space. Let me write right over here. Our velocity at t is equal to 2 must be between negative 160 and negative 80. So the question here, which of the following could be the velocity of the truck at time t equal 2? That value has to be between negative 160 and negative 80. So the only possible answer could be choice C, right? So answer must be C.